So how high throughput do you think this would be? So like if a biochemistry lab or a different lab wanted to use the Smart Center, how many student groups do you think you could get in there in one class time?
You mean like one time, like simultaneous, like at the same time?
Yeah, so there's a particular lab that a class would do. How high, I guess, how many students can you get?
So I would say usually like 2 to 3 people will be like the limit in the for one instrument. So that's why we think it's more like a research program rather than like a regular course. Yeah.
Great. Thank you, Jamie. Last, we'll have Nate, who's going to tell us a little bit about some modifications he's done in Gen Chem.
Cool. Thank you very much. All right, so today I'm going to talk about integration of Arctic snow research in the General Chemistry Laboratory. This is Chem 125, 126. A few people to thank. The instructor for this course, also my research advisor, Professor Carrie Pratt. There was one other FFGSI in this course, Steve McNamara. We had a postdoctoral advisor, Dr. Stephen Wang. A few undergrad instructors, Mark, Evan, and Alexa. We had a collaborator at the University of Washington who collected our snow in the Arctic. Our chemistry librarian, Dr. Yu Lee, helped out with integrating scientific literature in this course. And then Dr. Julianne Burton was our kind of research program officer who helped give a lot of background support for this. So, kind of give you a quick course overview. This course was taking obviously as the FFGSI project, but also underneath this program called the Authentic Research Connection, ARC, which is an HHMI grant that funds these kind of classes where we create a research-based laboratory experience in the classroom to give students hands-on experience in how real science is conducted, basically research in the classroom. The goal, obviously, of this is to increase STEM retention. These courses are focused in general introductory classes, so we're targeting freshmen and sophomore students, giving them exposure to research, so hopefully in their later years they'll pursue maybe grad school or just undergraduate research, something like that. Quick demographics, we have 2 sections with 27 students total, so pretty small sections, a lot of interaction between the instructors and the students. We have 77% female, and then 2 in comprehensive studies program, which is a program in the University of Michigan that brings in people from underrepresented groups. So, kind of broad goals to reach in the classroom. This is applied to snow chemistry for us, but can be applied for any other course where you're putting research in the classroom. First, obviously, you want to have them develop these research methods. How exactly do you carry out the research? They want them to be able to translate that, the data they generate from that research, into some critical thinking about what does it mean, and then put that into the context of scientific literature and understand how the students decide to communicate and how does their data fit into this larger picture of the scientific community. And then finally, we want them to be able to communicate their results to others through presentation and writing skills. So kind of think about this as a broad, whole picture idea of research that we as graduate students participate in every day, but we want the students to be able to get that entire experience. So, briefly, I'm not going to belabor the science bit too much here, but some of the research questions we're exploring in this class is what the chemical composition of surface snow in the Arctic is, and how does it impact atmospheric reactions in the Arctic. And also a little bit about what are the impacts of sea ice loss due to climate change on this Arctic snow. So this is really cool for me because this is actually research I'm doing for my PhD. So it's cool to have undergraduates, freshmen, sophomores, pursuing this in the lab and kind of helping this project along. Because this actually will be generating usable data for me for my research. So aside from this greater research thing, we also wanted to integrate the concept of snow chemistry into the General Chemistry Laboratory. This is still a Chem 125, 126 section, so it's necessary for them to gain these basic lab skills so they can progress to later courses in chemistry and still have the same knowledge if they had taken a normal Chem 125, 126 section. So how we did this is basically every time we presented a general chemistry concept, a lab, we put a snow chemistry spin application on it. So if we're going to make solutions and dilutions, we're going to have them make calibration standards to run on the ion chromatography system in the Pratt lab, which they use to analyze their snow samples. If we're going to look at precipitation reactions or titration, we're going to determine the chloride content of snow melt by the Moore method, which is basically precipitation titration. You can look at freezing point depression. Obviously, an easy one for this is freezing point depression of road salt. So we actually went to the city of Ann Arbor, University of Michigan, got their road salt, and determined how much of a freezing point depression the road salt that we use on Ann Arbor snow has. And then also looking at buffering and pH, buffering capacity and pH of ocean water and snowmelt. And then things like redox reactions and absorption spectroscopy. We have them make CO2 gas, which we use to calibrate a chemical ionization mass spectrometer in our lab to study reactions of atmospheric gases off snow. And so we kind of did that as a way to see how you would basically calibrate an instrument in a research laboratory. And then finally, for the larger part, the capstone research project, which is really where the authentic research experience comes in here, is we have them analyze individually, come into the Pratt lab, and use our ion chromatography system to analyze a snow sample collected by our collaborator up in Barrow, Alaska. They were collected a couple different times, locations, then also from the surface and at different depths here. So there's basically different variables that they can look at in their research. And they each had an individual snow sample, and then they combined all their individual analysis together as kind of a bulk data set. And they're going to present that through a poster in a research manuscript. So again, kind of getting back to the idea that you're getting the full cycle of graduate experience. They're going to do the research. They're going to do the critical thinking, think about how their snow analysis fits in with the other snow samples and also the greater literature, and also be able to present this and communicate their ideas in the poster and research manuscript. So a full cycle here. So briefly, how did the students react to this? Obviously, this course is still ongoing. This semester's not over. But this is from midterm feedback. I think we got a really good response from this. And they really liked that we integrated the snow chemistry concept throughout. There's a consistent theme, so they weren't just doing kind of random experiments. So they liked it had a theme that gave a purpose. They really liked the research questions, kind of really challenged them. I think they had a chance to do some really good critical thinking. And they really enjoyed also the environmental aspect, thinking about what's going on in the snow outside, what's going on in the world. So I think that was pretty cool. We actually also had students that have already asked to join our research lab. I think that's a big benchmark of how successful this course was, and hopefully not just our research, but in general they get more interested in research now they've had this experience. So finally, I want to advertise we are having a student poster session, so they're going to present their capstone research experience next week, Wednesday, in the lower atrium. It's completely open to the department, and if you would like to volunteer as a judge, it's pretty casual. You just walk around and talk to them. Please contact Julianne Burden. So with that, I'll take any questions.
Are there any questions for me?
What were some of the challenges that you had in taking some of those field research and making it happen?
So there's the time. So for the ion chromatography, each run takes 15 minutes. You have to do triplicates. So the students had to come in, basically took away one lab and they had to come in individually for 1 hour. So as you imagine, that's a lot of commitment for the graduate students and undergrad. That's why we had a huge team, so people could rotate in with that. And then, in that hour, as everybody knows, scientific instruments don't work all the time. So a lot of times they would come in for an hour and they do their analysis, but results just would not be successful. So that had a lot of backlog where we had to basically, do those analysis over again because it's not really fair to ask them, come in again, extra time and do those analysis. So it's a challenge, but I think it's worth it in the end because they do get to come in and seeing the excitement of them, walking around our lab and being able to actually, hands-on use the instrument. This wasn't like, they were sitting by us while we did all this stuff for them. We taught them how to do it and then pretty much let them run free using the IC. So it's a big time commitment, it's a lot of effort. That's the big drawback.
So Nate, is this something that you foresee going into the general population for 125, 126?
Yeah, so we're hoping to expand this, a couple more sections next year, actually. And I think getting the full research experience would be challenging just because of the time commitment, but getting more courses where there's a consistent theme throughout the entire course would be great. That's the great thing about 125, 126. It's so general in its breadth right now that you can really apply it to biochemistry, environmental stuff. Stephen Maldonado is doing a photovoltaics section of this, so really there's a lot of room to apply these major themes to this chemistry course, and I think that's even more than the research. I think what the students really liked was that there was this theme that was consistent throughout, where they felt like every experiment was building on top of each other, and they weren't just walking to the lab one day and learning about something completely different than they were last week. There's that continuity, I think, is the big thing that can be applied to large courses.
You said your overall goal was increased STEM retention. So are you, like, were you able to ask them any questions before and after? Like, are they interested in going to?
Yeah, so we have some survey stuff. Class isn't over yet, but I think just for the fact we've had more people that actually that didn't seem to have interest in research before, actually approach us directly and asking if they could continue the work that they started in this course. I think that's a good indication. And overall, I think the midterm feedback, overwhelmingly positive that they, enjoyed the research experience. I think that's cool, because I mean, at least for me, I remember, seeing research as kind of a big scary thing. I think the thing with this course is really just showing like, yeah, you guys actually just did authentic research. You guys made like individually, generated like novel data from Arctic snow. That's pretty cool. I think that translated them to like realize like, oh, I can do research. It's not this big scary thing. That's hopefully we'll see that in our evaluation at the end of the semester.
All right, thanks, Nate. And thanks everybody for coming. If you have any questions for any of the presenters, feel free to mingle and talk.